Here I picked up this Hewlett Packard 400D AC voltmeter a couple of days ago, and it is interesting in that it has some the ranges are enormous. It goes from 0.001 volts full scale to 300 volts full scale, and that's RMS. And I've checked the specifications on it, and it goes to about 2 megahertz, I think. So it's a fairly wideband unit, very useful for audio work and low-end amateur radio work. This was a very high-end unit in its day. These came out in 1954 and were mainly used in laboratories and probably university laboratories and high-end industry for research. This would have been used as a standard, and all other instruments, all other cheaper instruments would be calibrated against this unit. This is unusual in that it's a blue color. I've never seen that before with Hewlett Packard instruments of the day. In the 50s and early 60s, most of the Hewlett Packard instruments of this 400 series were kind of a browny color, and I've also seen a kind of a beige color. This blue I've never seen before. It doesn't look like it's been repainted because it looks like it's been baked on, and the inside has no spillover. So maybe this was just a limited run of a certain color. But anyway, I plugged it in, and the light comes on, and it doesn't make any noise. And the meter in various ranges was kind of shaky. But as I turned it, left it on for a while, I didn't smell anything, so it didn't seem like anything was overheating. It stabilized, and it even and it kind of stuck down here as the lower. So I zeroed it using this here, and I was making measurements, and it's fairly accurate, but it'll need to be recalibrated. So I've opened it up, and all the tubes are there. It doesn't look like it's been worked on. Here's what the inside looks like. Here's all the tubes and a whole lot of electrolytics in here. I'll have to check through them. And I would say that this has not been used for a whole lot of hours, because that tube there looks like it looks pretty clean inside. Normally, if you've had a tube that's been used for a lot of hours, they tend to get kind of cloudy inside. Right here you can see the range switch, and you've got a whole lot of Black Beauty capacitors in there. Black Beauty capacitors are known for their due to age, they do break down. Although these won't have any, would never have had any voltage on them, so they might still be in pretty good shape. But the one thing that definitely will be a problem with this will be the electrolytics, and that is probably the cause of it, the wavering of the, and not zeroing. So I'm going to have to test all these electrolytic capacitors. Here is the component side. You've got a selenium rectifier stack here. Here's the bottom of some of the electrolytic capacitors. Here you've got resistors all neatly mounted on a type of circuit board. And here is, I think this box here is for frequency compensation. That's what it says here. There's a couple of what look like germanium diodes there. And that's pretty well it. Comparing this to a cheaper vacuum tube voltmeter at the time, you can see a big difference when you look at the schematic. So here is the lower part of the unit with the bottoms of the electrolytics and a lot of other calibration circuits. Here are two diodes. They look like germanium diodes. I don't know what they're for. Right down here, get that down there. If I can get it right. Right here, if you can see it. This is a selenium rectifier stack. That's probably the main power supply. And you can see down here, I'm going to check these electrolytics here. There's one here, and there is another one over here. There and there. Those are the first ones I'm going to check. The inside of this was quite clean, amazingly clean. Just a little bit of dust and a bit of a couple of spider's webs, but just with a little bit of vacuuming, I got all the dust out, or most of it. Yeah, you can see that this hasn't been used much. It's just very clean inside, and it's a very nice specimen. Best I've ever seen of a meter from that era. So something like this is a real pleasure working on, and not much wrong with it. I think all I'll have to do is replace a couple of electrolytics. I'm going to do the minimum to get it to work properly. So here I'm going to use this device to check the various electrolytic capacitors in here. Now this device checks ESR, which is equivalent series resistance. That's a better way to check the value of or the condition of old electrolytic capacitors than checking their actual value, because as capacitors dry up, the ESR goes up, and it's much more predictable as it gets older. As the ESR goes up, it becomes very leaky, so it destroys the capacitor's ability to filter. So I'm going to check each segment of this capacitor up here. Yeah, let's give it a try. Turn it on again. Whoops. Put that on there again. No. Wait till it... Okay, now put that on. It discharges. So that's got ESR of 4 ohms, which is not too bad. It's got a higher ESR, but it hasn't gone over the limit, which is 15 ohms I've got it set at. Okay, so I'll put it on the third one. That's only just a little over 2 ohms. It's pretty good. Let's measure that other one. One that was 50. Now it's only 2.5. Try this one again. Oh, that's gone down a little below 2. Let's try this one again. That one that was high has changed. That's down to about 8, 6. So these do change also as you test them, but a really bad capacitor will show up bad. These probably have been forming the few times I've plugged it in. Reforming, I should say, because this meter has been sitting around for a long time. So anyway, I'll check this one and this one. First I'll check the lower one. That's reading bad. Try it again. Grounded. That's bad. Whoops. Oh, that one isn't good either. Try this one. Yeah, so that one is not good. None of them are good. None of the segments are good. Okay, so that means that the SR, and this is over 50 ohms, so I'll have to get hold of some capacitors. These are 450 volts at 20 microfarads, I believe. So let's check the others. Okay. Okay, that one's okay. Now, there are 3 in here. So those seem to be quite normal. I'm going to check this lower one again, and I'm going to put this chassis connection closer to it. Something isn't making connection here. Okay, I've hooked it up again. One of the leads had come off. Now I'll try this one. That's bad. Try it again. Try this one again. Try this one again. Okay, those are bad. Now I'm going to check these red ones. I believe this here is the negative, and this is the positive. Okay, that one's okay. Now, try this one. Okay, good. And I think this is negative here on this one. That one's fine. Now I'm going to check this one up here. It'll be a bit harder to get to. So there are 3 electrolytics that are on the meter. So I'll test the first one here. That one's good. Now test this one up here. Next we're going to check this one here and see here. There we are. That one's good. That last one's good too. So the only other one I have to check is this one here. Okay, so here we are. Check this one. So that's okay. I forgot there's one last electrolytic, little one right here that I forgot to check. That one's fine. It's got a ESR of 2 ohms. I was a little mistaken here. This area here, that capacitor there, the reason that I was getting a high ESR is because, not because that capacitor is bad, it's because the capacitor is a very high value. It's 1500 microfarads and it's rated at 15 volts. Looking at the actual schematic, you can see here I'm measuring 12.6 volts, and that one is 6.3 volts. There, 6.3 volts, and that's 0.2 of AC. So what that is, it's a low voltage circuit. When I first looked at the voltage, I was thinking that it was the bogged down, but it isn't. That is this circuit here. This is the selenium rectifier, and this is they turn it to DC for the filament supplies to better regulate them. So you've got 6 volts and 12 volts. You got some 6 volt tubes and some 12 volt tubes. And this is the power supply for the filaments. So we don't have a problem there. That capacitor is apparently in okay shape. So all the capacitors, all the electrolytics in this unit seem to be okay. I'll check the voltages in the on the high voltage capacitors too, just to see how they are. There we've got, when it first comes out of the rectifier, we have that would be, there's the rectifier tube here. That would be about here, where it goes on to here, 20 microfarad, and we're measuring 426.8. And you got 2 volts of ripple, which is quite acceptable. So the voltage at that point there, where I'm taking it right there, is right here. Right here. After you got the rectifier, you got your filter capacitors, and here's your series pass tube, and this is your regulator. So here it says 245 volts, and we're measuring almost exact that. So that's working the way it's supposed to. The power supply, got the right voltage there. And the regulator seems to be doing what it's supposed to be doing. So I think we're okay in that department. I'm feeding a 100 hertz, 1.553 volt signal into, it's a sine wave, and I have an RMS, a true RMS reading multimeter in parallel with this meter, and it's measuring pretty close. It's measuring 1.55, so that's very close. So this meter doesn't seem to need any calibration, at least at that frequency. I'm going to try it at different frequencies, but I'm going to have to use a different RMS meter because this fluke that I'm using here doesn't measure very well above a few hundred hertz. So I'll have to use another meter. But for the time being, it's fine at 100 or 60 hertz. So the problem that I see here is when I take the signal off, the fluke, or not the fluke, the Hewlett Packard meter doesn't zero. It zeroes fine when I turn it off, but when there's no signal, even when this is shorted, when I short the two terminals together, it doesn't properly zero. It doesn't seem to affect the actual accuracy of it, but it's just kind of annoying. I like to have them zeroing. I'm just kind of an OCD that way about meters. So I'm going to have to look into that. So that'll be something I'm going to explore in the next segment. I've got a problem here, actually two problems with this unit. You can see when I turn it on, the meter is jerking to the right. If it was working properly, it would just gradually, as the tubes heated up, it would gradually move to the right and then drop back and zero. But this, it jerks very abruptly when it's warming up, and then it eventually jerks less and less and less, and it'll have an intermittent jerk every now and again. And as the tubes heat up, it will gradually go back, but it won't zero completely. So I've got this scope meter here, and it's set on DC, and I'm looking at this point right here, top of the meter circuit here. Meter's in the middle. You got two diodes up here, and it comes off the plate of the last tube. So I should be reading, according to the schematic, 131 volts there. So 131 volts DC, it's 111 volts DC, with a lot of noise riding on top of that. Now look at this. See that jumping all over the place? So I've got a noise component riding on top of that 111 volts, which is averaging around 0.6, but sometimes it goes up to over 1. And the frequency is jumping all over the place. It's like an oscillation of some kind is taking place there. My suspicion is that one of the tubes is noisy. It might not be the last one, but it could be one of the ones further down the chain, because there's 5 tubes, V1 to V5, one amplifying after another, so it could be any of them. So I'm going to start pulling tubes and try and isolate that noise. So I'll start by pulling V4. So I pulled V4, and the V5 is oscillating by itself. And it's actually quite an accurate oscillator. It's 120 hertz, and it's producing 0.404 volt waveform riding on top of about 105 volt DC waveform. Interesting. Now I'm going to substitute V4 for V5 and see what happens. I'll isolate it and see if another tube put in the same position, the same tube but put in the same position, will also oscillate. Then I'll be able to determine if it's the tube or the surrounding components. So I've substituted another tube, and it's still oscillating. So I don't think the tube is the cause of the oscillating. I don't think it's a gassy tube. So it's components around the tube that are causing it to oscillate. So next I'm going to check the resistors, capacitors, anything that could be causing this feedback. So I'm going to check the resistors and the capacitors around the tube V5. There we are. Get that right there. Right here we've got a 3300 at the top, 10K, and then we've got two down at the bottom, which are the 510 and 51. So I'll just check the values of each one of those. So the 10K is just a little above 10K. That seems to be okay. Now let's go to the one above that, which goes to up to the B+, should be 3500. Okay, I've measured the top one, and it's supposed to be 3300, and it's 3500, so that's fine. According to the schematic, this resistor behind this capacitor here should be 510, but it is 105, and I believe this capacitor is wrong too. Someone's modified this. Now, if I take that point to ground, it's 53, but that resistor says 105. So this point to ground is the right amount. It's 53, what it's supposed to be, and that capacitor up there that's in parallel with the 100 ohm might be, I think that's wrong. I think it should be 0.5. It's kind of interesting why someone would have changed that. I'm going to maybe look and see if there was a modification that was done on this. Next, I'm going to check and see what is on the grid, input grid, control grid. So now I'm checking the grid resistor. This is just a, I think they're called a grid stopping resistor, and it's supposed to be 47, and it's 50. So that one's good. So I've taken the two diodes off, which are basically the load on that tube, and I'm getting on DC, it's jumping around, the voltage is jumping around, as you can see there, the DC voltage, and it's got a substantial amount of noise riding on the signal. So let's go to AC. We've got 60 volts of noise at a frequency of just around 3 to 4, then it jumps up. It's jumping all over the place, from 119 to usually around 120 up to 200 and something. So it's got noise, and it's 60, now it's 41. So you've got a substantial amount of noise on there, very much. So that obviously is not the problem. It's not causing a feedback problem. Now I'm going to try, the next thing I'm going to do is put in the capacitance and resistance that it says in the schematic. Here I'm going to solder in the proper 510 ohm and 0.5 microfarad capacitors that should be in that circuit. There we are. So I put the two components in, the 0.5 microfarad capacitor and the 510 ohm resistor in parallel, and I want to see if that's changed a whole lot. It hasn't. In DC mode, it's the voltage is 160 volts approximately, and when I put it in AC mode and adjust the frequency so I can look at it. Oops, wrong one. So you can actually see the frequency there. You can see it. It's about 7 kilohertz, and the waveform is about 0.6 volts RMS. So nothing much has changed except that the oscillation is stabilized, more or less. There shouldn't be an oscillation there, so I'm going to have to delve into this further. So it came down to testing tube V3, and it tested really strong. Stronger than the ranges that are provided by the manufacturers. It tested up about 2500, which is quite interesting. So I also thought I'd check it for shorts. And look at the shorts, the light there that says fuse. Or actually shorts there. So 1, 2, 3, not 4, and 5 position. It's got shorts. So it amazes me that tube is even working, amplifying. But it just shows you. So I would assume that that is the one that's causing the oscillating. So I will check the other two tubes, V2 and V1, that are in the amplifying string, and I'll see if I have one of these or put it on order. So I found the tube that is bad, and I've checked to see if I have any of that type, but I don't. So I've ordered it, and it's a common tube, and it's very cheap. So I'll just order it, and we will put it in when it's ready. But in the meantime, I'll just, since this meter's working, I'll just finish this video and end it here.